All right, pre-calculus, believe it or not, it is week 6 of our online learning. It's flying by. Hopefully you're doing well. Again, if you have any questions, feel free to ask me. This week, you can see we've talked about limits by substitution. We've just done the general idea of a limit from tables or graphs. You've seen that on Khan Academy. You've seen one-sided limits as well. And so now it's time to look at these two kind of this week. And we might finish with this week. This just means the questions are actually going to require a little bit more of analysis. They're a little bit harder level of questions, whereas these are, kind of just direct substitute, plug it in, look at the graph, get the answer. This takes a little bit more nuance. So continuity just means, is a graph connected fully? And there are certain criteria that needs to be met. And what we're going to do is we're going to investigate this on the first Khan assignment, and then we're going to find the types of discontinuities of a function in the second, and then we'll probably end up having a third. So let's understand continuity in terms of limits by kind of jumping into the fire and looking at this Khan assignment right here. Okay, so continuity just means, is the graph fully connected? Fully connected, and we'll see what that means, but hopefully you would obviously say the answer is no, because of what's going on at 3 here. The graph is not connected, therefore it's not continuous. But why is it not continuous mathematically? We have all these conditions. So can we find the side limits of this graph? So does 3 from the right exist? Yes, it's -2. So as you approach 3 from the right, you would go to -2. Does 3 from the left exist? Yes, it's +2. So this box gets checked off. So in other words, there are conditions for continuity, 4 of these. They all have to be true in order to be continuous. So far we have this one that is true. Now, does the limit as x approach 3 exist? No. Why? Because the left and right don't agree. If they don't agree, the general limit does not exist. So this is unchecked. All right, but we need to check all that apply. But this is one reason continuity fails. Is g defined at 3? We haven't talked about this, but yes, g is defined at 3. If I were just to ask you, what is g of 3, it would be this point right here. That is where at 3, the graph has something closed and filled in. Okay, so g of 3 is just -2. All right. Now, again, because this is left unchecked, this is definitely going to be left unchecked, but there are actually times where you can have a, b, and c, but your function is still not continuous, and we'll probably end up seeing that. Okay, so up next we have this graph. Again, hopefully you would say it is definitely not continuous, and this one is going to be a little tricky because first it says, do your side limits exist? And this one is actually not true, because the one on the left, so 6 from the left, is unbounded, and that's technically non-existent, so don't check this one off. Also, does the limit in general exist? Well, again, definitely not. If A is not true, B is definitely never going to be true. All right, if you can't take a left and a right, you can't combine them and get the same value. Is g defined at 6? Is there any closed circle at 6, anywhere on the graph that's closed and filled? And the answer is no. So it turns out none of these are true. Because A, B, and C fail, D is definitely going to fail. So there we go. Okay, up next we have this graph. Now this time, again, our side limits exist, but we can see that our general limit does not. There's no, these are going to different values. The left-hand limit is 4, the right-hand limit is -3, so they're not the same, so your limit fails there. And then is g defined at -2? No, there's no closed circle anywhere here. All right. Now, one thing that is true, we haven't seen it yet, but that closed circle doesn't even have to meet here. The closed circle could be, for instance, right here, and then g would be defined at -2. It would be 1. But again, the only box we get to check off is that there are side limits. Okay, I'm actually going to do this a few more times, maybe 1 or 2 more questions, just to really drive home this concept. Now, while my computer's loading for some strange reason. What I can tell you is what you're doing in this is you are understanding continuity in terms of limits. So notice the first two questions were limit questions, and then we were talking about function values and continuity in C and D. And it turns out every discontinuity you saw has a specific name, and we'll talk about those in a second. Okay, so let me try this again. So we can maybe see a few different types of questions. Okay, this question, finally, at -1, do your side limits exist? Yes. From the left, it's going to 0. From the right, it's going to 0 as you approach -1. Does the general limit exist? Yes, because we said both the left and the right were going to 0. Is it defined at -1? Yes, there's a closed circle at -1. It just so happens to also be the same value as the limits. So because all three of these are true and they're all pointing to the same place, that's what makes this function continuous. All three of them are going to the same value. For some reason, Khan Academy is going a bit slow today. Hopefully we'll see. I'm really just waiting until I see A, B, and C true, where D is not true. Alright, this is the same as we saw before. The left and right hand limits agree. The general limit does not exist, but it is defined at 2. Move them faster. I really wish I knew why this was going so slow. Trust me, I've even restarted my browser and everything. Still doing that. Okay, this time, again, none of the above. Can't even take a side limit. There's no closed circle anywhere. So there's no side limits, which means there's no general limit. Now, just because those two are true, there could be a function value, but again, I didn't see any closed circle. Let's hope we see the one I wanted to see. Nope. All right, side limits, general limit does not exist. It is defined. So maybe I'll just draw it out. Okay, so the last thing that could be true, now I'm going to kind of go off of this Khan Academy wording here. Let me just draw you a picture. Say I had something that looks like this. And I were to ask you about the continuity of this function. So A would be true. Your side limits do exist. B would be true. Your general limit exists because those side limits are going to the same place. C is true because there is a point where at this x value, maybe it's x equals 1, where the limit or the function is defined. There is a closed circle here. However, the answers for A and B are approaching, I don't know, like 1.5 or 2 or whatever. And the answer for C, the function value is -1. So A and B are going to a particular value. C is going to a different value. So A, B, and C are true, but it's still not continuous. All right, because they're not all the same value. Here the limit's approaching again, I don't know, 1.7. Here the limit's approaching 1.7. Here the function value is -1. They're not all the same, so it's not continuous. How do you make it continuous? Well, you fill the circle. Now it's continuous.